I've recently been working on a model for the visual question answering dataset. So I treat this almost as a translation problem where I have an encoder and a decoder, which is a transformer when you combine them, and I use a visual transformer encoder as the encoder and GPT-2 small model as the decoder. And so the way I frame this is that the image patches, I guess, go into the encoder like this. Image patches, and then the decoder decodes the text. Answer the following question. Question goes there, and the answer, and then it's asked, then prompted for the answer, and then it generates the answer. So the loss function here is the negative log likelihood of this text being generated from the image patches passed into the encoder, because this is a vision transformer. And so I trained this for one epoch on an RTX A5000 model from Vast AI, which was about like 20 cents an hour. It took like 3 hours to train, so it was pretty good. And then, yeah, so if I run it now, one thing I realized is that while the model may not be very good at directly answering questions because it can't really learn to distinguish between what is an okay incorrect answer, such as saying the synonym of a correct answer, versus a not okay correct answer or incorrect answer, which would be like saying the wrong color completely, like blue instead of red, for example. So the model learns to generate plausible answers basically, but they might not always be informed by the image. One thing that I also tried was, because the whole string, this whole string is part of the loss function, what I can do is generate questions in addition to generating answers for specific questions. So let me try another example. Yeah, so one example is like, what are the meters used for? And answer is parking. What kind of payment do these machines accept? And answer is cash. So these question answer pairs were generated by the model because the model thought like, oh, it could be a reasonable question and answer that could appear in the data set, which is visual question answering. The visual question answering data set. Here, let me try another example really quickly. I think some of the questions and answers are incorrect, but pretty much what I think could be done for this is that I could first train the model to generate appropriate questions for the image, and then I could train it based on the questions it generates to generate appropriate or correct answers for those questions. The reason I think that'd be useful is that I wouldn't require so much manual annotation, because some of the results are synthetic from the model, but corrected by humans, so they're still correct. You could consider this like a form of reinforcement learning with human feedback, and I think it could help like visual question answering better align with human values, which might make it feasible to use for like assistive technologies, such as for helping blind people, and potentially to help automate some visual tasks as well. If like a language model such as GPT-3 could prompt this model, get some visual intuition from the whatever like a camera is seeing, and then act on that. So yeah, I think that's the project so far. So more updates will come.